Alright guys, so last class period we went through our gas law equations and setting up our gas law equations and identifying them, whether they were Charles's law, Boyle's law, Dalton's law, so on and so forth. Now we're going to take those exact same problems that we set up last class period and we're going to actually solve them. So this should be a pretty quick lesson. So again, like once we go through, we've labeled everything, we figured out what equation we're going to use, and we simplified it to where it had only the variables that we needed. So now all we got to do is take the numbers that we labeled in the problems and substitute them in place of the variables. So here we go. So P1 is my first one that I have. So I go up in my problem and I find P1, which is right here, and the number is 700. So 700. The V1 is right next to it. So remember, in math, things that are side by side, that means multiplication. So I'm going to put this in parentheses. My V1 is right here, 65.0 equals P2, which is 880. And then V2, that's what I put a box around. That's what I'm looking for. So that is going to be X. Okay? So now we have all those. I need to take and I need to solve the problem. Right? So in your calculator, we're going to do 700 times 65. And I get 45,500 equals 880x. Now I need to solve for x. So in order to get x by itself, remember we have to do the opposite function. So 880 is being multiplied by x, so I need to divide by 880. What you do to one side, you must do to the other. And now you plug it into your calculator. The number on top always goes into your calculator first. And then we are going to round to 3 significant figures according to this problem. So when you round to 3 significant figures, we're going to get 51.7. So x equals 51.7. And I was looking for volume, right? And volume is in liters, so it should be liters. And there we have it. So we're just using basic algebra to solve our problems. All right, moving on to the next problem. All right. So again, this one said, what is the total pressure of a mixture of gas if the pressure of oxygen was 0.719 atm, the pressure of carbon dioxide was 423 atm. So plug it in. P total, well, that's what I am looking for. So P total is my x equals the P1, which is over here, plus P2, and I have no other P's, so that's it. Pretty easy, right? X equals, we plug that into our calculator, we add those two numbers together, and we get 0.719 plus 423, and we get x equals 423.719 atm. Make sure you are always including your units. Okay? Alright. Our next problem. If a gas has a volume of 750 milliliters at 25 degrees Celsius, what would the volume of the gas be at 55 degrees Celsius? Now, here's the first time we're seeing some of the variables not in the correct units. Just a reminder, let's see, I want to do a hot pink. Alright, so just a reminder, okay, so volume must, oh, not must, but must, volume must be in liters, okay, and temperature must be in Kelvin. Okay, so right now, okay, right now our volume is in milliliters and our temperature is in Celsius. So we need to do some conversions first before we can actually plug in and solve these equations. So let's go back to my pen. Alright, so if we remember, in order to convert from milliliters to liters, we have to move the decimal place left 3 times. So right now, 750 has a decimal right behind it, so it should go 1, 2, 3. So I'm going to rewrite it over here. V1 is equal to 0.750 liters. To change temperature from degrees Celsius, we must add 273 to it. Alright, so 25 plus 273, and we get T1 is going to equal 298. Okay. And remember, I like to get rid of numbers once I'm done with it. And then we'll do 55 plus the 273. And we get T2 equals 328. Okay? So I don't need those. Now, these are the numbers that I am going to be using now. Alright? This is it instead of the other ones. So now we are ready to plug our numbers into our problem and solve our equation. So V1, that's this one. So V1 is 0.750 over T1, which is 298, equals V2, that's my question, right? That's my X, over T2. Okay? We've plugged everything in. This is a proportion, so in order to solve for X, we must do the butterfly method. So we're going to cross multiply and then divide. So 328 times 0.75 divided by 298. Put it in your calculator all at one time. We are going to round our final answer to 3 significant figures because that's how many each one of our numbers has. So X is equal to 0.826, and it's volume, so that's liters. Okay. So again, making sure that you're copying all of this down. You should have all this already written down and you're solving it. Okay, if you don't have enough space, you can solve on a different piece of paper. But I need to see all the math worked out. Okay? Alright. I'm going to pause here for a minute. I want you to pause it. I want you to try to solve this one on your own and then unpause it when you're ready to move on. Alright. So, now we have, again, volume and we have temperature. Okay? Volume and temperature must be in the correct units. Volume must be in liters, while temperature must be in Kelvin. Okay? So our volume is already in liters, and our temperature is in Celsius. So we must convert that temperature, right? So this temperature, remember, we must add 273 to it. Okay? So we have 25 plus 273, and you're going to get 298. So we're going to say T1 equals 298. Right? Same thing over here, 0 degrees Celsius. 0 plus 273 is just 273 Kelvin, right? Now we got everything in the correct units. So now we just plug it in and we solve. V1 is 2.85 divided by T1, 298, equals V2, which is X, over 273. We've plugged everything in, now we solve. Butterfly, so cross multiply and divide. And again, make sure you are rounding to the correct number of significant figures. We need 3. So X equals 0.926. And we're looking for volume, so that's liters again. Okay. So pretty easy, right, guys? The hardest part before we even solve the problem is picking out all the information and labeling the variables correctly. Once we have that done, then it's really easy for us to just plug things in and solve it. Alright, so again, what's the temperature of 25.5 liter balloon holding 3.5 moles of carbon dioxide at 32 atm? So we decided this is going to be PV equals nRT. This is the ideal gas salt. So let's go ahead and let's plug in some numbers. In place of P, we have 32. Oh, I'm going to put this somewhere else. I'll put it right underneath it, right? So P is 32. The V is 25.5. The N is 3.5. The R, well, R is a constant, right? Go ahead, let's put that in hot pink, right? So remember, R is the ideal gas constant. So you must get this from the star chart. It should be in your notes, but let's just say we can't remember where it is in our notes, right? You can always go over here to Ms. Towery's website. If you click on resources, we're going to scroll right down here. So constants and conversion sheets, right? Now, let me see if I can get my, I need a marker. All right. If you look right here, here are the R values. Now, in order to decide which R value you are going to use, you have to look at the pressure. So we have ATM here, KPA here, and MMHG here. That's the only difference in the units. So the pressure unit is what determines which one you're going to use. Okay? So, our units, if we look back over here, let's see if it'll let me do it. Our units was an ATM, okay? Which means we needed to use the first one, the 0.0821. Okay? So, And then the T. T is my question, so T is my X. Okay? All right. So now we're going to go ahead and we're going to start simplifying the left and the right hand side of this equation, and then we're going to solve for X. So we're going to take we can go ahead and plug that into our equation. 32 times 25.5, and we get 816 equals, we can plug this into our calculator. And we get 0.28735, right? And then we still have our X out here. Now all we gotta do is we need to solve for X. So we solve for X by moving whatever's next to it to the other side. Remember, we gotta do the opposite function. So X is being multiplied by the number next to it, so we're gonna divide both sides by the same number. These cancel out, leaving me with just X. So I get X equals, then I do 816 divided by the 0.28735. And we get and that was temperature, so that is Kelvin. Okay. All right. Moving on. Okay. We've plugged everything in. Check to make sure all your units match. We're dealing with volume, so make sure it's in liters. Moles, it's the correct unit all the time. So here we go. Well, as long as it says moles. If it said grams, we'd have to do something different. Alright. So, plug and chug, right? In place of V1, we have this one. So 3.68 over N1, 1.2. Equals V2, which is 4.3, over N2, which is my X. Everything's plugged in. Butterfly it, cross multiply and divide to solve for X. And we get X equals 1.4, and we were looking for moles, so moles. All right. Here we go. All right, P1 over T1 equals P2 over T2. Okay, make sure our temperatures are in the correct unit. Temperature T1 is in Kelvin. Our pressures match up. They're both millimeters of mercury. So that is one thing I forgot to tell you. Make sure that if you have pressures, and it's something like this, P1 and P2, that your pressures are in the exact same units, okay? So here we go. P1 is 126 divided by T1 equals P2 over T2, which is X. Cross multiply and divide. And you get X equals 90 Kelvin, because we were looking for temperature. Hey, so this one, a blast furnace gives off so many unpleasant and unhealthy gases. So if the total pressure is 0.99 atm, the partial pressure of carbon dioxide is 0.05, And the partial pressure of hydrogen is 0.2. I want to know the partial pressure of the remaining gas. All right, make sure you are plugging everything into the correct space. Okay, so P total is 0.99 equals P1 plus P2 plus P3, which is X. Go ahead and simplify your equation. Go ahead, add those together. So we get 0.99 equals, let me move this down, 0.05 plus 0.02 gives us 0.07 plus the X, right? Now we have to solve for X. Remember, we must always do the opposite function. So right now, 0.07 is being added to X, so the opposite of addition is subtraction. So minus 0.07 minus 0. What just happened? These cancel out. So you get 0.99 minus 0.7, and you get X equals 0.92, and your units, ATM. Alright, so just a few more. Alright, again, I'm going to let you solve this problem. And pause when you're ready. Alright, so we have our equations. We need to go ahead and we need to make sure that everything is in our correct units. Pressure must be in pressure can be in any units. Sorry, volume must be in liters. Currently my volume is in milliliters, if you notice. So all I gotta do is take it out of milliliters by moving the decimal place left 3 times. So here's my decimal, 1, 2, 3. So V1 is equal to 0.458. 1, 2, 3. 0.477. All right, plug it in and solve. So P1 is 1.01 times V1 equals P2, which is my X, V2. Telling y'all are going to become so quick at this because we're going to do it so much. We are going to solve, so we're going to simplify this. Okay. Remember, to solve, we must do the opposite function. So the opposite of multiplication is division. And we get X equals 0. And I'm rounding to 3 significant figures, okay? 970 ATM. And just a heads up, you will be taking a test over all this when you come back from spring break, so really make sure you're paying attention. Alright, PV equals nRT. Alright, plug and chug, right? So, my P, standard pressure, is 1. Okay, I don't know why it's not letting me write over on the far right, but it's not, so I'll do it here. 1. The V equals the N, which is X. The R, remember, check the R, and we got to use the pressure units, ATM. The one that has ATM is the 0.0821. And then the T. Right now the temperature is in Celsius, remember it must be in Kelvin, so 0 plus 273 equals 273 Kelvin, right? Let's go ahead and let's start simplifying some of this. I can go ahead and multiply these two together, which just gives me 2.00 equals X. Multiply these two together. Then we will solve for X. Remember, multiply X being multiplied by 22.413, so we must divide by 22.4133. Once you solve for X, play it on your calculator, solve for X, and you get X equals 0.0892, and I was looking for moles. Okay. All right. So a tank of compressed air has a maximum volume of 825 liters. The volume gauge reads 388 liters. When there are 24 moles present, what's the maximum number of moles the tank can hold? Plug it in and solve it. V1 is 825 liters. N1 is X equals 388 divided by 24.00. Cross multiply and divide. So 825 times 24.00 divided by 388. We get that X equals 51.0 moles. Alright. Almost done. So a gas at standard temperature and pressure is increased to a pressure of 286.4 kilopascals. What is the new temperature of the gas? Well, remember, standard temperature is equal to, let me get a different color. Standard temperature is equal to 0 degrees Celsius plus 273. So 273. Pressure is equal to 1 ATM. Alright? Now, something you should notice. My pressure here is in kPa. Here it was ATM. They're not the same, so you must convert them. So if I go back over here, again, here are your units of pressure. Okay? 1 ATM is equal to 101.3 kilopascals. So since our standard temperature is 1 ATM, that's the same thing as saying it's 101.3 kPa. So I'm going to go back over here and we're going to say that this is equal to 101.3 kPa. Okay? So make sure we're using all the correct numbers. We're using this and this. Plug our numbers in and solve. So my P1, 101.3, divided by T1, which is 273, equals P2, divided by T2, which is my X. cross multiply, and divide. So 286.4 times 273 divided by 101.3, and we get that x equals 772, because I am rounding, Kelvin. And that is it, guys. That is how we solve the problems. So we have to combine the lesson from last Thursday and Friday with this lesson in order to really solve these gas law problems. Okay? So you must first identify your variables. Second, make sure that everything is in the correct units. Volume must be liters. Temperature must be Kelvin. Your pressures can be any of the three, but make sure your pressures are in the same units. Okay, and moles is just moles. Then you're going to find your equation, set your equation up, plug in your variables, and then solve. Okay, make sure you have all of this copied down. Okay, all in your own handwriting. Take a picture of this and go ahead and add it to your assignment and turn it in. It is due by the end of today. Alright, I know I'm off testing today, but it is still due at the end of today. Besides that, guys, have a wonderful rest of your day. I will see you next class period.